Okay, let's dive straight into this explainer. If you're studying for Cambridge Mathematics, whether you're tackling syllabus code 0606 for additional math or pushing through 0580 or 4024, you already know that opening that exam paper can feel, well, a bit like stepping into a post-apocalyptic wasteland. It's an unforgiving landscape of tricky, multi-layered questions, and today we're navigating that exact wasteland to claim your ultimate grade treasure. Specifically, we're taking on one of the most notoriously difficult, trap-filled topics on the entire syllabus, solving complex problems involving arc length and sector area using radians. We're completely transforming your approach today. We are taking you out of pure survival mode, where you're just scraping by for marks, and moving you into absolute, unquestionable mastery. Grab your notebooks, because this strategy session is going to change how you look at exam papers forever. So, let's start with a really important question. Why is arc length and sector area one of the absolute most misunderstood topics year after year? You might be sitting there thinking, well, it's just plugging numbers into S equals R theta, right? How hard can it be? But the principal examiner reports, the actual documents written by the people marking your papers, they tell a completely different story. They note consistently that students fundamentally misunderstood this area because it almost never requires just one simple calculation. It demands multi-stage analysis. It's practically never a straight, easy line from reading the question to writing down the answer. Instead, you're dealing with bizarre composite shapes, overlapping circles, unstated geometric assumptions, and the absolutely crucial, often forgotten conversion between degrees and radians. When candidates face these multi-layered 6- or 7-mark problems, they freeze. They panic. They completely lose sight of the logical progression required to earn those sweet, sweet method marks. But today, we're going to fix that by reverse engineering the paper and showing you exactly what the examiners are desperately hoping to see on your page.
To really understand the trap here, I want you to picture a classic Cambridge past paper question. It's asking you to calculate the shaded area of some complex geometric design. Now, let's look at two typical candidates. First, we have Alex. Alex looks at the question, panics a little, and just completely overloads the page with raw mathematical facts. He's writing down formulas for degrees, formulas for radians, scribbling down everything he remembers from the textbook, but providing absolutely zero analysis linking those facts to the specific shape in front of him. Then, on the other side, there's Sam. Sam rushes through. She spots a radius, spots an angle, punches some numbers into her calculator at lightning speed, writes down a final decimal, and completely ignores the command word which explicitly said, show that. So, what happens? Both Alex and Sam leave a massive trail of red pen marks on their paper. They've left huge amounts of grade treasure buried in the sand just because of their approach.
To make sure you don't make those same mistakes, here is our tactical roadmap for today's explainer. Step 1. Mastering radians and sectors. Step 2. The method mark strategy. Step 3. Systematic problem solving. Step 4. The top 3 examiner warnings you must avoid. And finally, Step 5. The context connection.
Let's jump right into Section 1, Mastering Radians and Sectors, and really understanding how you're actually being assessed.
So look at this breakdown. The assessment objectives for this specific topic target 3 very distinct cognitive domains. We've got 33% for knowledge and understanding, 33% for application, and a massive 34% dedicated entirely to analysis. I really want you to think about what that means for your revision. If you just memorize the formulas, if you just know the textbook definitions inside and out, you're only tapping into that first 33%. Raw knowledge is simply not enough in 0606. You have to take that knowledge, apply it to a novel, probably really confusing composite shape, and then critically analyze which overlapping sector needs to be subtracted from which triangle to find that tiny shaded region. That heavy 34% weighting on pure analysis, that is exactly the battleground where the A-star candidates completely separate themselves from the rest of the pack.
And here is the secret weapon for nailing that analysis category: cross-topic connections. The examiner reports explicitly highlight this year after year. Listen, in additional mathematics, a question about arc length is rarely just about arc length. It's almost certainly going to be integrated with trigonometry. You'll probably have to use the sine or cosine rule to find a missing chord length before you can even begin to think about calculating the sector area. It might be tied into coordinate geometry, or hey, maybe even basic calculus. You have to build these advanced causal relationships in your head. When you see a circle problem on that paper, your brain needs to automatically instantly scan through your entire mental toolkit: triangles, trigonometric identities, algebraic manipulation, the whole shebang. Bringing all those disciplines together is the advanced analysis that totally satisfies that top cognitive domain we just looked at. Moving on to Section 2, which is honestly a game changer: the method mark strategy. and how to earn points for the process. But hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, you want to have these strategies in your feed.
Okay, let's talk about method marks. This brilliantly illustrates how Cambridge examiners actually grade your paper. They reward the methodology, the process over the product, when you use appropriate terminology in clear formats. Let me break this down because it's absolutely crucial. In these intense analytical subjects, the final correct answer at the bottom of the page, it might only be worth one single mark, but the logical steps leading up to it could be worth 3, 4, or even 5 marks. These are your method marks. They are awarded for systematic analysis and evidence-based reasoning. Let's say you miscalculate a tiny, silly arithmetic step on line 2. You accidentally wrote a 3 instead of a 5. But your subsequent method using that incorrect number is perfectly logical and clearly laid out. Guess what? You can still secure the vast majority of the points through what's called error carried forward. But if you're like Sam and you just rush to a final answer with no clear working, you lose literally everything if that one final number is wrong.
Let's do a really quick 30-second visual challenge here. Take a look at these two approaches. Notice the glaring difference between a flawed, generic chunk of math and a perfect, highly structured Peel paragraph. Yes, you heard me right. Peel. Point, evidence, explanation, link. It's not just for English or history. Structuring your logic matters immensely in mathematics. Your point is identifying the correct geometric principle you're using. Your evidence is extracting the specific numbers from the diagram, like stating the radius is 5 and the angle is 1.2 radians. Your explanation is your clear step-by-step algebraic working flowing down the page. And finally, your link is tying that final calculated value strictly back to the specific context of the question, making sure you perfectly satisfy a command word like evaluate or show that. The structure on the right is exactly how you turn those brutal red pen marks into brilliant, beautiful green check marks.
Now let's get into Section 3, Systematic Problem Solving. We are going to break down the exact sequence that top-scoring candidates use to process these multi-stage nightmares. I want you to memorize these 5 systematic steps. Lock them in your brain because they guarantee you capture every possible method mark on the board. Step 1. Identify key elements. Pause and ask yourself, are you working in degrees or radians? Don't get caught out by your calculator settings. What is the exact radius? What is the specific shaded region they want? Step 2. Apply relevant principles. This is your cross-topic connection phase. Do you need the cosine rule first to find a side length? Step 3. Execute analysis. This means writing out your working cleanly, linearly, straight down the page. Step 4. Verify results. Take a breath and look at your answer. Does that sector area actually make logical sense compared to the whole circle, or is it way too big? Step 5. Present in format. Did the question ask for exactly 3 significant figures? Did it explicitly ask for the answer in terms of pi? By religiously following this standardized sequence, you are building an absolutely impenetrable fortress around your grade.
Okay, look right here. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get back into this interactive workshop and master this data.
We are going to do a rapid 60-second interactive data scan challenge right now. Look very closely at this complex data table outlining arc length, sector area, radians, and contextual constraints. I want you to mentally scan this and try to extract the core trend. Look at how the sector area scales up as the radian measure increases. Notice that contextual constraints column on the far right? That is exactly where the examiners hide their deadliest traps. For instance, what if the problem states the angle theta must be strictly between 0 and pi over 2? If your calculations spit out an angle outside that constraint and you just accept it, you have missed a critical, grade-defining piece of the puzzle. Data interpretation skills like this are vital before you even pick up a pen. You have to be able to extract those constraints rapidly, interpret those proportional relationships, and draw evidence-based conclusions immediately. If you instantly spotted the nonlinear relationship in the area column compared to the linear one in the arc length column, congratulations, you are already thinking exactly like an A-star candidate.
Let's move straight into Section 4. I've combed through the principal examiner reports to reveal the top 3 fatal mistakes, the massive red flags that you absolutely must avoid. Warning number 1 is vague details. You simply cannot afford to leave your analysis floating in midair without specific details.
Let's do a quick find the flaw challenge together. Imagine a student writes this sentence on their paper. I found the area of the shape by using the formula and taking away the triangle. Okay, what is the fatal flaw there? It's entirely hopelessly generic. Which formula? Which shape? Which of the three triangles in the diagram? Examiners despise this. They demand highly specific analytical details. Now let's look at how a top-tier candidate writes it. I calculated the sector area OEB using half r squared theta with a radius of 5 centimeters and an angle of 1.2 radians, then subtracted the area of triangle OAB calculated via half AB sine C. See the massive difference? One is vague, just crossing its fingers and hoping the examiner guesses what they meant. The other is precise, specific, and mathematically rigorous.
Warning number 2, formatting failures. Listen to me on this one. Ignoring presentation conventions loses you incredibly easy method marks, so always double-check your annotation and formatting. This is where so many naturally talented mathematics students trip up and lose their A star. You might have the cognitive processing power of an absolute supercomputer, but if you suffer from formatting failures, you are going to be heavily penalized. We're talking about forgetting strict conventions. Are you using proper headings for different parts of a massive multi-stage calculation so the examiner can actually follow your brain? Are you using the correct mathematical terminology? For example, please don't just write the curved bit. Use the actual term arc length. Are you clearly annotating your diagrams? If you decide to introduce a brand new variable to solve the problem, let's say let x be the length of chord AB, you must state that explicitly on the page. Proper formatting isn't just about neatness. It's exactly how you communicate your intelligence to the examiner.
And warning number 3, which is honestly a massive mark dropper, the context disconnect. This means providing answers that are completely isolated from the actual scenario given in the paper. Let's set up a quick scenario in your head. Imagine a word problem where the sector area represents a physical field where a farmer's sheep are grazing. You grind through all the complex radian math, you do the calculus, you figure out the area is 45.6 square meters. If you just write down the number 45.6, double underline it, and quickly turn to the next page, you've missed a vital link. The context actually matters to the examiner. A disconnected number is an incomplete answer. You need to tie that final numerical value back to the reality of the scenario, which brings us perfectly right on cue to the final and most important strategy of all.
Section 5, the context connection. This is how you seal the grade and prove true evaluative thinking. Take a look at this quote. This perfectly illustrates the golden rule, straight from the Cambridge principal examiner's mouth. The classic mistake is providing generic answers. Always link every point to the given scenario. Let that sink in. If the exam question is a practical physics application about a pendulum swinging through a specific arc, your final concluding statement shouldn't just be S equals 12. It should be the total distance traveled by the pendulum bob is 12 centimeters. I know it sounds pedantic, but this isn't just window dressing or wasting time. It is the ultimate, undeniable proof that you understand the real-world application of the mathematics, totally satisfying that critical 33% application domain we discussed way back in Section 1.
Furthermore, top-scoring candidates take this a step further by evaluating evidence quality, identifying assumptions, and testing alternative interpretations. Evaluative thinking requires you to constantly question the constraints of the problem you're solving. Is there a physical limitation to the mathematical model provided? For example, if you are calculating the area of a cross-section of a concrete tunnel using sector area formulas, what underlying assumptions are being made about the perfection of that circle? Justifying your mathematical decisions with clear written evidence puts together a totally watertight case for your answer. Mastering this high level of evaluative thinking is the final crowning piece of the puzzle layered right on top of command word decoding and Peel framework application.
Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. I want you to really think about what a jump of 2 entire grade boundaries means for your academic future. That's the difference between merely scraping a pass and absolutely dominating the 0606 syllabus with top marks. But knowing this strategy intellectually isn't enough. Execution on the day is everything. You have to take these frameworks, the rigorous formatting, the relentless hunting for method marks, the context connection, and apply them to blank past papers over and over until it literally becomes muscle memory. So here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by without having this kind of actionable intelligence in your corner. I want to hear from you now. Drop a comment below with your target grade for mathematics and the biggest challenge you're currently facing with your revision. Our team reads and responds to every single comment. Also, make sure to like and share this with a study partner who needs to hear this. AC exams, your Cambridge success starts here. Seriously, engage with the community down below. Publicly writing down your target grade is the very first psychological step in holding yourself accountable to the insanely high standards required by Cambridge mathematics.
As you keep practicing those past papers with these fresh techniques in mind, I want you to ask yourself a serious question. Have you truly mastered the examiner's mindset? Are you truly ready to ace this wasteland of tricky exam questions? You now have the ultimate survival map. You know exactly how to decode the command words. You know exactly how to secure every single method marked through systematic working. And you know how to dodge the deadly traps of vague details and context disconnects. So, look at that next complex arc length and sector area problem, not as a trap designed to fail you, but as an opportunity to showcase your analytical brilliance. Keep pushing, keep practicing, and go claim that grade treasure.